fenders, and so it's a bit rough. It's a bit of a beater GTR, but I've got it, and I couldn't be happier to have the chance to own something like that. So
Yeah,
it's
that's pretty awesome. I live in New York, so
Mhm.
we know a thing or two about rust. Unfortunately,
Yeah,
it's our curse too. But so it's right-hand drive then.
yeah, yeah.
Cool.
So it's a rusty right-hand drive GTR, but I
Nice.
mean, with the way the market's going on those kind of cars, uh, it's nice to just have one, and
Yeah.
I won't be afraid of scratches or anything like that. I can just enjoy it.
Yeah, it'd be a great car to set up for drift or something too. Like you can doors open to do really whatever you want to do with it, which is cool.
Yeah, mostly what it does is sit these days, but
Man, I know I have a 1997 Honda Prelude that's been sitting in my garage for years because I've
oh,
got a
nice.
just miscellaneous things I got to do. It's been sitting for long enough that I really need to do like timing belt on it and stuff. But it's like it has a Jackson supercharger on it, which goes
Oh,
like
very cool.
over top of where the timing belt would be. So it
Hmm.
like takes a nuisance of a job and makes it that much worse. So at that point, it's like just pluck the engine out and we'll deal with it. But then once you take the engine out, it's like okay, well let's see. This snowballs into a million things you got to do, and then it turns into
Right.
something that I never get done.
I know that feeling all too well.
Yep.
So is
Yep.
that's an H series
Yep. It's an
engine?
H22.
Okay,
I have
very
so my
cool.
first the first car that I purchased, I was just saying the other day, was a 1990 also Prelude.
Hmm.
And that was probably my favorite car. I would love to have another one of those flip ups. It's the third
Hmm.
generation. And I've always had half a mind to take the H22 out of my current car and stick that into a third gen and then do like a K swap or something into the fifth
Yeah,
generation. But we'll see. Maybe someday.
it'd be pretty great. I
Yeah.
uh, I've never played with Hondas, but Full Race actually really got started in the Honda scene
Oh, no kidding.
20 years ago. Yeah, yeah,
Nice. Yeah, they're
yep.
fun. They're pretty easy to work on. Andrew and I were just talking the other day, and it's one of those things where it's like you've got a 12, a 14, and a 10 millimeter, and you can take apart the whole car.
Hmm.
It's nice. You don't need too many like specialty tools or anything like that. They're pretty fun.
Yeah, our production manager actually has a DC2 Integra, but it's all-wheel
Nice.
drive,
Oh,
K-swapped,
cool.
big
That's pretty
turbo.
awesome.
Yeah, it's
That's
pretty
pretty awesome.
amazing.
Yeah, they're a lot of fun. A lot of fun, but like I say, it's one of those things you got to have time to work on them.
Hmm.
But they're fun. But the third generation Preludes are the same way. It's as the Skylines. It's like the prices have just gone through the roof on them. I paid a couple $100 for my car. Granted, it had some damage and stuff that I had fixed, but yeah, the prices have just gone crazy on them. They're just anything that gets rare, I guess, right?
Yeah,
People want them and they're
yeah.
hard to
Anything
get.
in that kind of late '80s, '90s enthusiast kind of platforms, they're all
Yep.
just through the roof.
Yeah, all of
So
the people who like looked up to those cars when they didn't have the money now have the money and just start scooping them up.
yeah, it's really wild.
Yeah, yeah, it is great. I mean, prices on any used cars have really gone through the roof, but yeah, they're tons of fun, tons of fun. Hopefully, I'm starting to collect parts for my Prelude, so hopefully I'll get that back going maybe next year. Hopefully, get it all
Mhm.
apart back together.
Yeah, yeah. I've been slowly chipping away at mine. I just did the fuel injectors and fuel pump, and now I just need to swap some bigger turbos onto it, and
Nice.
should be good to go.
It's a twin turbo 26, you said, right?
Yeah, yeah. 2.6 liter inline six twin turbo.
Awesome.
Yeah,
What a great engine that is.
yeah. It really is. I mean, it has its problem areas, but you can't really beat the way an RB26 sounds. So.
No, they just sound phenomenal.
Mhm.
Phenomenal. Really, any straight six of that era, all
It's
the ones
true.
alongside of those just sound so good. So good. Obviously, we'll take a look at another sort of new generation of them today
Generation
as we
straight
get
six,
going.
yeah.
So, yep, yep. Which is probably a good transition into our show this morning. So we're looking about right on time, so we might as well just get going. So
Perfect.
uh, thank you everybody for joining us today. My name is Jesse Sprague. I'm going to be the host for this episode of SOLIDWORKS Live Design. I am absolutely pumped for this episode. I think I'm probably more excited for this episode than I have been for any of even my own episodes. Today, I am joined by Mat Velders with Full Race, and you may have seen some of his work with Papadakis Racing video that we had a little while ago with their setup for their Supra, Formula D, Formula Drift car. And today he's going to give us a little bit more background on some of the stuff that went on in designing projects like that, and his mindset as he goes through, you know, those kind of things. I'm absolutely excited. I'm going to try to stay out of the way as much as possible, but and just hear what Mat has to say. So Mat, thank you so much for joining us. How you doing today?
I'm great, thanks. How are you?
I am fantastic, absolutely
Yes.
fantastic. I'm chomping at the bit to get going. So before we get into the actual good stuff, do you want to give us just a quick rundown of who you are, Full Race is, and maybe just a quick background on this project, you know, if people haven't seen the video?
Yeah, sure. So we're Full Race Motorsports. We're the turbo experts. We are distributors for all of the world's major turbocharger OEM brands like BorgWarner, Garrett, MHI. Yeah, so like you said, we started this project with Papadakis Racing, and I think we've been supplying turbo manifolds to Papadakis Racing for a long time, ever since they did the Scion front-wheel drive to rear-wheel drive conversion.
Yep.
And that car was using a Toyota 2AR four-cylinder. So we started supplying them with manifolds back then, and it's kind of continued along until the Supra platform.
Yeah, that's cool. That was going to be one of my questions. I was wondering if this was one of the first projects you had done with Papadakis, or if there was some history there. So that's pretty neat. You guys have been working with them for a little while now.
Yeah, so this was the first one I was involved in, but we've been working with them for a long time. So
Gotcha. Very cool.
they wanted to try something a little bit unique and kind of push the limits and explore some new technology. So they wanted to do a 3D printed Inconel turbo manifold, and that's where the project started with SOLIDWORKS and 3D Experience. So they were printing the manifold, and it was coming right down to the wire for I think it was Irwindale. It was the last round of competition for 2020, I guess. I'm getting my years all mixed up. COVID kind of made everything a little bit confused, but so they were working on the 3D print, and it was taking a bit longer than expected, and they weren't sure if they were going to be able to make the event with the printed manifold. And they said, hey, could you guys design a traditional fabricated manifold and build it and ship it to us? So I had the scans of the car, and Full Race had the manufacturing ability, and I was living in Canada at the time. So the car was in California, Full Race is in Phoenix, and I was in Canada, and I had 48 hours to design a manifold, and then Full Race had, I think, the rest of the week to actually build it and ship it to Papadakis Racing.
Wow. Okay. So I didn't actually have a sense of like the time scale of this. So this was like a really short span project.
Yeah. The fabricated manifold part was a real rush, and not a lot of sleep was had, but we got it done in time.
That's amazing. So it's just so I get this straight. So they had at Papadakis, they had designed the 3D printed side of it. And then, as you mentioned, they were not sure they were going to make it. And then that's where you guys came in sort of in the second phase of this.
I actually designed the printed manifold as well.
Okay.
Yeah.
Gotcha.
Yeah. And then, so I had kind of the layout for the manifold for the 3D printed file, and I kind of just saved a copy of it and rolled the tree back and kept all of the locations for everything, and kind of went through and connected the dots. But this time I was stuck with certain bend radii and certain there was a lot more constraints.
Yeah, sure. So just so I can get this out here while we're talking at the beginning, just to be sure to let you guys know, the chat is active. We're in the chat. So if you have any questions for Mat as we're going along, and I'll certainly be asking questions of my own, throw them in the chat because we are monitoring that. So if I see those pop up, I'll try to get those translated across. And like I said, hopefully I'll try to stay as much out of the way as possible so we can hear Mat talk. But don't forget to put that in there, of course, like and subscribe on the channel. But so, all right, so you did the 3D printed version of it as well. So when I watched through the video originally, when this came out or whatever, when I was watching through this, I was like, this is like the holy grail of design, because it like the cross section of skills that really like went into this whole thing was staggering. I mean, it was such a cool like blend of the final one that got used was sort of like traditional methods, but then there was like a mix of everything in between. There's 3D scanning in there. The actual first manifold that you made was the Inconel 3D print, so you've got a 3D printed final manufactured part. There's 3D printing just FDM pieces for testing and fixturing, and everything across that whole span went into this one project, which I think is really cool. It's kind of staggering to see like all of those, like it's a perfect explanation of like where we are in manufacturing right now, like the future, what's going to happen, what's going on right now, all blended into one thing, which is really cool to see.
Yeah, it was such a cool project to be involved in. I felt so lucky to get to do that, and yeah, to have that like really short time frame with the stack up of this 3D printing. I had never designed something that needed to be printed in metal before, and then right at the last minute to have to redesign it using more traditional methods. It was a pretty action-packed project. It was a lot of fun.
Yeah, absolutely. And like you said too, like there was that aspect of everything being everywhere, right? Which is kind of the story of how things are going nowadays too. And you mentioned using SolidWorks Connected and to try to address that and things like that. But that is definitely a growing issue where things are not always under the same roof anymore, which just adds another twist to things. Very cool, very cool. All right, so I'm going to try to stop talking so much. Do you want to start walking us through some of your approach to how you actually came at this one?
Yeah, sure. So the assembly that I have pulled up here now is, well, I guess once we finished the project with Papadakis Racing, we decided that this would make a good complete turbo kit. And
Sure.
so we started playing with the idea of developing it further into a kit that someone could actually buy to put on their Supra.
Yeah, so let me actually, I said I was going to stop talking, but I imagine
No
in this case, this actual powertrain was probably a good, because I mean, if you think 1,000 horsepower Supra, everybody thinks, well, you just do a 2JZ swap or something, which I think there is I think HKS has a 2JZ or something. I assume it was the Papadakis choice to stick with the actual drivetrain that comes with the Supra and work with that.
Yeah, I think because of his partnership with Toyota, he wants to stay more true to what the actual production vehicle was.
This is the free
and it's really turned out that I think, sorry people, but I think the B58 in a lot of ways is proving to be superior to the 2J. So he's really done a lot with the platform, and they ended up winning the championship last year. So
yeah, absolutely. It certainly seems
cool.
like it's a pretty solid one, and I'm sure from your end at Full Race too, it's nice to be developing on a newer platform that people are going to be using going into the future, right? The 2JZ, as awesome as it is, probably on its its last legs or so as far as production cars go and going into things. So it's nice to get a chance to develop on something new.
Yeah, I'll always love the 2J. I'll always love the RB26, but the B58 is definitely a very impressive engine, and it's cool to see some of the modern design changes between the modern inline six and the ones of the past.
Yeah, just kind of as we were going through prepping this, I dug into it a little bit more because I haven't really looked at that powertrain too much, but it does look really impressive.
Yeah, it's pretty unbelievable what these cars can do now. I guess some of the downside is the modern cars' engine bays, or the packaging is so cramped, and it's a big challenge, and it makes technology like 3D scanning and CAD software like SolidWorks much more important than it once was.
Yeah, absolutely, totally agree. All right, so back
to the turbo kit.
Yeah, back to where we were.
Yeah, so to develop the car, the Papadakis car was a completely stripped out race car. It in many ways, I mean, it resembles a street car, but it's very different in a lot of important functional ways that would impact a kit that someone would put on their Supra. Like, for example, the production Supras have the intercooler built into the intake manifold. Every time we post pictures of this kit, there's always comments, people saying, "You guys don't have an intercooler?" It's built into the intake manifold. It's a water-to-air intercooler, but the Papadakis racing car uses a traditional air-to-air front mount intercooler. So there's lots of important differences. So to work on the production kit, we partnered with Titan Motorsports in Florida, and they found a very generous customer who was willing to let us borrow their car for far too long to develop the kit. But so thanks, Ollie, if you're out there watching, we appreciate it. But we're really thrilled with how the kit turned out. So the production kit needed to be more than just a turbo manifold. It needed to include the charge pipe for the original style intercooler in the inlet manifold. It needed dump tubes, downpipe, and so the development of the manifold into a kit had a lot of iteration through that process. So they shipped the car to us. We work with Creaform. You may notice that this engine bay scan it's maybe a little bit over the top. It was a bit more than what was needed for the turbo kit, but I was kind of playing with a new toy and having fun with the handy scan, so got a little bit carried away. But so we scanned the engine bay and brought that all into SolidWorks and started with the original model that we did with Papadakis Racing, and so there was kind of a bit of a unique use of CAD software in this, where the manifold was fully built in CAD and fully designed in CAD and mostly built to that model. But a lot of the rest of the kit, what you see in this model here, like the downpipe and the dump tubes and the charge pipe, they were kind of it was more concept design in CAD. And then I worked with our talented fabricators here who we kind of went back and forth, and they'd look at the scans and the model, and we kind of figured out where things needed to be roughly and what we could fit. Like, it was really important to Titan to have a 3.5-inch downpipe on this kit, and it's pretty tight and it was difficult to fit. So that had us move the turbo position around a little bit. We had to move the wastegates around a little bit. There was not a lot of clearance in this area here, where you can see this Garrett wastegate here. It's tight to the frame rail. It's close to the downpipe, and you don't want to get too much heat around this top hat here to protect the wastegate. So I kind of would go through figuring out some layout concepts and what would or wouldn't fit, and the fabricators would kind of look at it and give me feedback, and we'd kind of go back and forth. And then once we had a good idea of what should fit and where, they took this image and went and laid it out on the actual car. And then, of course, there was a bit of back and forth.
It's such a great combination, sort of alluding to what I said before of, like street smarts and book smarts, right? You've got like this super high tech 3D scan or whatever, right? And then, at full race, you've got the knowledge to know exactly how things are going to lay out, and kind of join those two together is super cool.
Yeah, and I really like to defer to their knowledge, because most of these guys have been fabricating these kind of components on cars for longer than I've been using CAD software. So they have a lot of really good input. And I'm not going to pretend that I could do a better job in SolidWorks than they could on an actual car, but it definitely saves time to kind of work through some of those concepts and layouts in CAD, rather than the time and material that would go into them figuring this all out.
Sure,
on a
absolutely.
Car. Yeah, so there's a lot going on here. It's a big assembly. Well, for me, it's a big assembly, but yeah. So I worked through the concepts for charge pipes and downpipes and dump tubes, and then they kind of built something on the car, and then I ended up replicating what they built in SolidWorks afterwards, so that I could make like a drawing with a cut list and just kind of a general assembly layout for the downpipes and dump tubes. And then if we get some of the components CNC bent, we can use the models to check to make sure that they're what they're supposed to be.
Yeah, very cool. So in terms of heat, you mentioned obviously you're working on an exhaust system, so heat's a big deal.
Mhm.
How do you guys handle that? Do you do any like simulation or flow or anything, or just to see like where heat might be going? I know it's probably tough because it's in a moving vehicle generally, so there's a lot of air potentially flowing through there as well. But is there anything that you like, any tools that you use to try to get an idea of where heat might be going, or is it just like, an inch in between is going to be okay for what this component handle?
I'd say it's a bit of a combination. Some of the analysis work has been done, but Full Race has been doing this for 20 years, so they've got a pretty good feel for what will work and
Yeah.
what won't. But
Yep.
like, there's definitely concerns with like this. Here, let me hide some of these scans. This valve cover here is plastic, and it it can definitely take a lot of heat, but it's an area of concern for sure. And
Yeah.
actually, just recently, the Papadakis Racing GR86, which has a B58 swapped into it, unfortunately DNF'd at an event because their turbine housing was a little bit too close to that cover, and they thought that it would be good, but it wasn't quite. So lesson
Yeah.
learned.
Sure. Yeah. Sure. Interesting.
Yeah, so this, I mean, the approach to building something like this, you could start with the scans and pick your turbo location in CAD and sort of rough out your wastegate locations in CAD, or you could mount them in the engine bay on the physical car and pick what you like that way, and then scan the location and go about it that way. For this project, Full Race was already making a. So I guess I should back up a little bit. The 2020 Supras had a cylinder head that only had two exhaust port outlets.
Yeah.
Most of the manifold was built into the cylinder head. So cylinders 1 and 3 merged into one outlet, and cylinders 4 through 6 merged into a second outlet. So we were already building a manifold for the 2020 two-port cars, and so we wanted to use that turbo location as the starting point for this kit.
Okay. Now,
So
is there two different versions of this? Because when I was looking around a little bit, I did see some like that there. I saw the two port one, but then there was kind of that like French cleat design as well. Did the Super get a different head than other versions, or what was the difference there?
yeah, so the Supra for 2020 had a two-port head, and then starting 2021 onwards, they went to a
Okay.
six-port head.
I got you. It was just an update.
Yeah, so it was the two-port car was a 1 year only um, thing, and then they went to the six-port after that.
I see.
So
Now, as far as the turbo placement goes,
mhm.
who was making the decisions? You said you were working with Titan. Who was making the decisions on what turbo it was actually going to be, and driving the housing size and all of that stuff? Was that you guys, or was that Titan, or combination?
In the beginning, it was us when we were working on the initial two-port kit, and the kit was developed around a BorgWarner EFR 9180, which is, or I guess the 9280 is the largest one that they offer, but they're the same. They're the same overall size. Actually, that's one right behind me there on the shelf. So it's a pretty big turbo,
Yeah.
and that was what the kit was based around. Um, Titan wanted the option to fit larger turbos, which actually wasn't much of an issue with the original turbo location, but the requirement for the 3.5 inch downpipe made a pretty big impact on the turbo location. And
Sure.
we actually had to move it up a little bit, and it just bought us a little bit more clearance to snake the 3.5 inch downpipe down through and have it far enough away from cam cover and far enough away from wiring harnesses and that kind of stuff.
Yeah, yeah. We have a question that was, you mentioned that the Papadakis project was 48 hours, but how long does something like this take you to model? Did you do full model of this when you're going through that process, or was this mostly kind of, go part way and then you said you already had a jump start with the 3D printed one, but what was the time span on a project of building a model like this?
Yeah, so the one that I initially did for Papadakis was like 48 hours start to finish, and that included completely modeling the manifold. That included a couple 3D printed fixture models to locate the turbine inlet flange to the cylinder head flange, and that included turning all of the solid models into cam files that could be cut out on a CNC plasma cutter.
Cool.
Normally, I would say 48 hours is not nearly enough time to do something like that and think everything through properly. And it definitely had its flaws. The wastegate positions weren't the greatest. They're not as good as they are now. They were a little bit close to the frame rails, but in a race car that's using solid or near solid engine mounts, doesn't really matter.
Sure.
Something like this model that I have here was built over the span of probably a couple months, but that includes going back and forth with this project and spending time on other projects and juggling a much larger workload than just saying, you've got 48 hours, go.
Yeah. I don't think, I think our entire audience would say 48 hours is not ideal. Oh, very cool.
Yeah. So we started with a scan of our original 2-port manifold, and that kind of gave me the turbo location for this one here. So if I go back to the top of the tree here, I tend to just do, once I bring a scan in, I just do a 3D sketch that I've got X, Y, and Z dimensions and a couple angles so that it's let me open this up.
Yeah,
so I've got a fully defined sketch there, and
okay.
I don't have to worry about anything moving on me, and if I need to go in and adjust, I can just move it up or down or forward or backwards or whatever I need to do.
So now when it comes to the scans, because I know anytime I've worked with scans in the past, it's always like, oh, because you just like point this little gun at it and then you get a model. And it's like, well, no, that's not at all
Right.
how that works. There's quite a bit that goes into it. So what's your process for coming off of a scan for something like the manifold that you're actually going to need to reference? Do you go in and put a surface on there, or do you just rely on that sketch as just eyeball it off of that, or what's your process there?
Yeah, that's a great point. So we use Creaform's software to both do the scanning and modeling. And for something like a turbo manifold, I would usually, so I scan the 2-port, and I would pull a plane that represents the head flange, and I create a plane or a surface to represent the turbine inlet, and then I'll just pick up some locating features like some bolt holes or something like that, just
Sure.
enough to constrain it in 3D space, because I'm rarely actually using scans to reverse engineer something and replicate it. It's mostly, I just like to have a mesh in SOLIDWORKS to use as a visual aid for how much space I have to work with.
Yep, totally agreed there. Cool.
Yeah, so the scanning and reverse engineering part for what I'm doing is really pretty quick and simple, because I just need to get a mesh, get a few locating features, and then I can move on with the design work.
Yep.
But yeah, so from there it's just a lot of 3D sketches constraining the T4 flange location, some simple extrusions for the flange, some cuts. It's all pretty just bread and butter SOLIDWORKS features. I've got a 3D sketch to locate this collector piece. And yeah, I just kind of keep going through and locating everything with 3D sketches and doing. I really prefer to work with surfaces rather than solids. It's just kind of, I don't know, it's just what's happened over the years, but I tend to model everything as surfaces and do surface trims, so you can get these. Let me hide a couple things here. So I'll build this up as the surfaces, and then you get these cut faces. And
Yeah. Sometimes you do get a nice little extra bit of flexibility there with surfaces as long as you kind of know your way around the surface tools. I feel like a lot of people sort of shy away from surfacing sometimes because it seems like this big scary thing. But
Mhm.
you know, when I was teaching it, I would always just encourage people to go in and look at the first few features. It's like it's the same stuff as what you're doing with solids, right?
Right.
And it gives you a little bit of extra flexibility there, so you can kind of dip your toes into surfacing pretty easily and get and feel it out.
Yeah, I definitely I was guilty of that as well. I was kind of a bit intimidated by the surfaces tab and kind of
Yeah.
avoided it. But I had someone that I worked with years ago that was a great mentor. I was like, "What are you doing? Like, stop what you're doing. Just start using surfaces. You'll get used to it, and then you'll end up loving it." And he was definitely right. So
Yeah,
yeah,
that's the case. I always said like surfacing is kind of like speaking the language of SolidWorks because it's doing surfacing in the background. So if you don't know
right.
what it's doing, you're just kind of letting it do its thing. But if you can build the surfaces yourself, sometimes you've got a lot more control.
Mhm. Yeah, so it's I mean it's a really long design tree, but it's just lots of surface cuts and 3D sketches. All of the runners are built with 3D sketches.
Yep. I
Uh,
notice you're using folders in your tree. That's always good. Try to keep things organized.
yeah, and I mean this isn't my most organized tree. There's kind of a lot of stuff flying around everywhere, but the folders are definitely a lifesaver. Keep you from getting confused. But yeah, so this is runner number one. I like to set up equations for like the center line radius and OD and ID so that when I'm going through dimensioning things, I can just hit the little drop down and select a radius or select a pipe size.
Okay, so are you using global variables or what's the equation actually doing?
Yeah, it's sorry, it's just a global variable. Yeah.
Okay, yeah, cool.
Yeah, so once I hit smart dimension, I can just start typing the name in it. I can just autofill it and move
Yep,
on.
that's smart.
Because with a fabricated manifold like this, you're stuck to for the inch and a quarter. We have long radius and short radius. Don't really like to use the short radius if we can avoid them. And if I remember correctly, I don't think this manifold uses a single short radius. So that was a job well done, I guess.
Yeah, yeah, and that's just a factor of it just bending the pipe, right? Just physical limitations of actually making those bends.
Yeah, and these are actually they're pipe, so they're like it's a Schedule 40 pipe, and they only, I mean, you can get custom sizes, but the off-the-shelf long radius bend is it's really an ideal size to be using for something like this.
Gotcha. Yep.
But yeah, so I worked through the model with a 3D sketch for the center line, which is nice. You can go back afterwards and calculate runner lengths and do whatever you want to do with that. And I just do a whole bunch of. I do the whole runner as one 3D sketch, and then I like to create the actual runner as separate sweeps.
Okay. Yep.
And then each sweep represents one, like a 90-degree bend or a straight section. And then we prefer to work with 90s, 60s, 30s, 45s, occasionally a 22 and a half, but we like to stick to those because then we can just have them pre-cut and ready to go. So yeah, it's just a big puzzle, one runner at a time, and it kind of seems like you'll do something for the first runner and then the second one, and then by the time you get to the third one, you realize that none of the first part was going to work. And then back to the top you go, rework the collector, rework the runners, and it's just kind of that back and forth dance up and down your model tree until you get to the end.
Yeah, absolutely. Now, are you looking to balance the lengths of these, or is it just what is going to purely fit in the car, or what's your approach there?
I guess there's a few schools of thought when it comes to this topic, like the runner length topic. There's a lot of people would say that equal length is everything. A lot of people say it doesn't matter. I kind of lean somewhere in between. I mean, this manifold, if you look at it, you can see it's not quite equal length. Like number 6 is quite long,
Yeah.
number 1 is quite short. But I, it's not that it doesn't matter on a turbo engine, but it's not as critical. And my opinion is that if you can keep the amount of bends versus straight lengths kind of, there's a happy medium. Like runner 1 here is quite short, but it's almost entirely bends. And runner 6 is a lot longer, but there's a lot more straight section. So
Yeah, so back pressure more than anything almost you're thinking.
yeah, try and balance the pressure out. But to be honest, a manifold like this is, the design is probably 80%
Getting
driven
it to
by
fit.
the limited space that you have. So
Yeah.
I put as much effort and care into runner lengths and bend angle counts and that as I can. But at the end of the day, you kind of have to stick with what will fit and what the fabricators will make, because you know, you don't want to have a shop mutiny on your hand when you
Right.
make some manifold that looks like spaghetti and it costs so much to make that no one could ever buy it. And I did start down that path. I thought, I wonder if I could make one that's equal length, and it was cool looking, but you know, that someone could make it as a one of a kind manifold, but it's never something that can be
A production
produced
unit.
in
Yeah.
any quantity that makes sense. So
Yeah. That
that
makes
was
sense.
abandoned, but it's not too far off.
Very cool. We had a question from Robo CNC about what scanner you're using. You said you were using HandyScan
Yeah, it's a
Createform. Is that right?
HandyScan 700.
Okay.
So it's kind of one of the older generation laser scanners, which I also have a GoScan 20, which is it's one of the really old structured light type scanners, and it works really well for small objects and especially non-shiny, non-metallic objects. But when you're trying to do a nice detailed scan of an engine bay like that, or if you want to scan a manifold and see how it compares to the CAD model, I mean, you can spray parts with powders and go through all that, but
Yeah.
the laser scanner is great because you can just scan away and it doesn't care if it's reflective or not. It gets a good scan, so it's definitely a big time saver.
Yeah, for sure. Yeah, scanning can definitely be finicky and frustrating if you've got a scanner that's fighting you along the way. It's if you're going to do
Hmm.
much of it, it's probably worth getting something that works well for your needs.
Yeah, and it's nice. Like we were using a car that belonged to a customer of Titan's, and I really would prefer not to be spraying their car down with some sort of white powdered spray. It's nice to just be able to stick some dots down that don't leave any residue, and then
Yeah.
get in, get the scan, and get out, and not do anything too cruel to their car.
Right. Yeah. Yeah. And they did that, I think, in the Papadakis one, right? They used a ferro arm, so they ended up spraying it, I think. But yeah, when you're working on a customer car, that's a great point.
Hmm. Yeah, it's a huge help for sure. Big time saver. Yeah, so I mean, this is the manifold model. Lots of sweeps, lots of 3D sketches. I guess one thing that's kind of interesting that we did in the past, all the fixtures, we usually would have two fixtures, one for the collector portion, which for those of you who are not aware, the collector is the parts where the flow from the 3 or 6 runners collect together and merge into one section. So we've got the collector piece 1, 2, and 3 here. So from these 3 pieces upward to this flange, and then these 3 pieces here up to the flange, and the wastegate tubes are the collector. So we have a collector fixture that the guys use to fit everything up, weld that, and then there's a separate fixture that the collector gets bolted to, and the head flange, which isn't in this model, but the head flange here gets attached to that fixture, and then they take the list of straights and different degree elbows, and they connect the dots and build it. But it kind of started with the Papadakis project when we were in a big rush, and we hadn't tried it before, but we decided to make a 3D printed collector fixture here. So this is the model, and this gray piece was designed to all be just 3D printed in plastic, and these arms kind of screw onto the side, and it locates the two merge pieces here. It has a feature to locate the wastegate tubes, and then we have another tool that they use to orient or to assist with orienting the collector. But realistically, since we're cutting the pieces out with a CNC plasma, they can kind of, if they put this wastegate tube into this collector, they can rotate the wastegate tube and the three into one merge portion until they kind of line up, and that gives them the location. But it's definitely an art form, and once they weld the collectors and start welding runners, everything kind of moves and shifts a little bit, so they need to be able to accommodate for all that. So they don't build it exactly the way that it's modeled, but it's amazing how close it turns out.
Yeah, that is really neat. So these are just like regular FDM prints that you just do in-house, is that right?
Yep, just with PLA. Actually, I have the
PLA. Wow.
So this is the original one that I created, and I only intended for it to be a temporary piece, but it worked pretty well, and they just kept using it. So it's been modified a little bit. You can see, because like these collector pieces that merge into the flange have to be deformed. Like you can see, this is just a perfectly round pipe, and this port shape is very rectangular, and so they need to make those two pieces connect smoothly. And so there's a lot of crushing and air hammering and manual labor that goes into making that a nice smooth connection. And so where the pipe gets flattened and widened down kind of around the bottom of this fixture, I had gotten a little bit carried away and didn't leave them enough space, so they just modified it. But it's still going. I've been wanting to print them a new one with like a carbon fiber nylon filament, something a bit more durable, but this works amazingly well. So it's something that it's pretty accessible, and it really works.
Yeah, that is super cool. It's such a, we were kind of talking at the beginning about that, like kind of blend of old generation and new generation, right, of tools. But the printer is, the stuff that you can do and things like that, just in fixturing, there's so many applications. It's so cool when it turns out better than you expect, right? You throw something together,
Definitely.
and this is incredibly helpful. And if it breaks, you just print another one, and right in house.
Yeah, and it's like a few dollars in plastic, and it saves a lot of time. The guys love it. It's been really fun working with them on some of these types of projects, because it's nice to be able to quickly make tools that save them lots of time and effort, and it's a really instant gratification type project when you can just make a little tool that saves them some time.
Yep, that's really cool.
So this is one of the finished collectors.
Wow.
That came out of that plastic print.
Yep.
And you can see everything's all been crushed and deformed to match that port shape really nicely. And you can kind of, I guess I should zoom out to the model here and see if people can get a bit of a look at both at the same time. But so that's the finished collector there. And then from there, we use a CNC plasma to cut out any of the straight pieces and any of the collector pieces. So that actually it uses 3D printing as well, because what would be the best way to show this? I'm going to hide this fixture. I'll hide these flanges, and I'm going to hide pretty much everything. Actually, I could probably just isolate something, can't I? It's funny, I've been using SOLIDWORKS for years, and I think only a month or so ago, I realized that there was an isolate tool, and it's been saving me a lot of time, and now I can't find it.
It
Oh,
is funny how
that's embarrassing.
things like that happen because you know, there's you're saying earlier you're self-taught on a lot of things. I'm self-taught on a lot of things too, and
Yeah,
you sometimes miss those like things that seem really obvious by the time you come around to get to it, but you just haven't come across it, right? That happens to me all the time.
yeah.
It's like, oh my gosh, where has
How
this
did I
been?
not know that? Yeah.
Yeah, where has this been the whole time? Now it's sitting right in front of me. I don't know how I didn't see that this entire time, but
Yeah,
yeah,
so a
I
bit of
mean,
a bit of a fail on my part. I've advertised the isolate tool. I can't even find it, but I would do it the old-fashioned way. So when these pieces get cut out, you have like this is a plane, and this is a plane, and this is also a planar surface.
okay,
But the CNC plasma can only there's like a piece of tube like this, and the cutting torch can only ever be normal to the tube.
okay,
So as the tube rotates and it moves and cuts, it can't actually cut that exact shape out with the flat planes. So the plasma saves a ton of time getting a rough shape, but it's not actually the final shape that you need to have everything fit together properly for
okay.
TIG welding. So this is how it comes out of the plasma. And then I also printed some just PLA sleeves so they can slip this over the CNC cut tube or pipe, slip the sleeve on, use a Sharpie, mark the edge, and they know that the way that it cuts, I have it set to cut the profile of the ID. So that location, the ID of the cut piece should be pretty spot on.
Yep.
And then the Sharpie line gives them this outside profile on the OD, and they can just use a big mean belt sander to take care of the rest.
Yeah.
But it saves a ton of time. So yeah, like part of the process of designing a manifold like this is for me to prep those files to be cut as well. And
Yeah, that's really neat.
yeah, so the way that I usually do that is I just do a surface offset of 0 millimeters, and that gives me the inside profile. And then once you do a thicken, say it's like 3.5 millimeters wall thickness, you get that same sort of shape that the plasma cutter can do.
Very cool.
And then I create the sleeves to go over top with really, it's more just surface offsets and cutting with a plane. So these are all the printed sleeve solids that slip over top of the wastegate pieces and the collector pieces that they can cut out. And I mean, you don't need to use a CNC plasma to do this either. You could model a collector in CAD and use one of these sleeves to mark out the lines and
Sure.
cut it with a bandsaw or an angle grinder or whatever you want. You can get the same result. The CNC plasma just saves us a lot of time.
Right. Yeah. Yep. Yeah. I think there was some chatter in the comments about water jet potentially. Yeah. There's a lot of ways to get that done right, but
Yeah,
that is cool.
and there are tools that could cut the pieces with the planar surfaces, but there's kind of a balancing act between how much we use it, the cost of the machine, and et cetera, et cetera. So we landed on the CNC plasma, and it was the right price, and it saves the right amount of time. So that's where we landed on that.
Yeah, manufacturing is always a balancing act, right?
Mm-hmm.
How long is this taking? Is it worth buying another tool to do it?
Right. Exactly.
Cool. But that's a great, way to kind of get best of both worlds there with your, what you're doing, making a marking device that saves a ton of time. That kind of lands you right in the middle, right? You're using a 3D printer on top of the, the cutting method to try to shave some extra time off of that, which is really cool.
Mm-hmm. So once we have the collector made in the 3D printed fixture, it goes on to the second fixture where they mount the collector and the head flange. I didn't drag that one out here, but so from there they have a list of bends, and the plasma cuts out the straight sections, and they just have to start connecting the dots. So they will end up creating something like this, which, let's see if I can on the spot figure out which runner this is. I want to say this is probably runner number 2. Yep, this guy right here. So they fit it all together, tack weld it, and then it goes on to a CNC robot welder. And the finished runner comes out like this.
Cool.
They're really beautiful, flawless.
And that's
welds.
done at Titan?
Nope, we do that in-house as well.
Cool. Really neat.
Yeah, the partnership with Titan, I mean, they're probably one of the most well-known names in Supra drag racing, and so they were a great partnership to get us the car, provide some feedback on what turbo sizing they would like to see for their customers' goals.
Gotcha.
And then we essentially produce the kit from them. So if you want to buy one of these kits, you can head over to their website and pick one up. But yeah, we do all of the manufacturing of these manifolds in-house, design and manufacturing.
Nice, that's awesome.
So once the runners are all robot welded together, it gets connected to the 2 flanges, and this is the finished product.
That is so cool.
Making all kinds of noise, banging things around. But yeah, so that's kind of the 5-minute overview of how the manifolds get made.
That is really cool. And I see Jeff is commenting in the comment section that you got Frederick Asbo was testing the car for or driving the car for Papadakis. So you've got quite a test driver there for the first run of these. He's
definitely
the winningest driver in Formula D, I think, still. So you've got a guy who knows what he's talking about testing the first round.
Yeah, you couldn't ask for a better partner than Papadakis Racing to use and abuse some of your products and make sure that they work.
Absolutely.
But yeah, the rest of the process was just a lot of back and forth with the fab guys and SolidWorks, and like we wanted to make sure that the Garrett wastegates could fit, that the TurboSmart wastegates could fit, and the Tile wastegates could fit. So they're all fairly similar in overall dimensions, but that was a bit of a balancing act. It's just a lot of constant balancing of variables.
Yeah, and especially with a piece like this where you're kind of working around other people's geometry, like you said too, right? You're trying to make it as universal as possible because not everybody builds their car the exact same way. So that is an interesting consideration too, that most time you have a production unit that's just you build it the way it's going to be and then it goes out the door, right? But this is specifically for applications where people are putting their things together differently. So that is an interesting point too. Yeah, definitely, because like wastegates are one of those topics where certain people swear by one brand and other people need to have a different one. So it was important to get all the major wastegates to fit. Yep, very cool.
We actually also it was kind of a bit of an experiment that worked out pretty well, which was the charge pipe. We did open this charge pipe. We did a 3D printed fixture for this as well, just to create the prototype one. So it was same idea. It was all printed in PLA, and it allowed us to quickly put together a prototype charge pipe. And we ended up changing the design a bit for the production piece to give a little bit better clearance around some of the water lines and things that didn't pick up so well in the scan, but it definitely was a good head start on the charge pipe. So there was, yeah, I mean, it just goes back to the power of an inexpensive 3D printer. We made this fixture, we had a spacer for different throttle body spacer options, and we just kind of played around with it until we got the charge pipe that we liked.
Yeah, very cool. There's so much power and flexibility there with printed stuff.
Yeah, definitely.
Now, this kit, you mentioned earlier that the Papadakis had a full intercooler and everything, but this kit is designed just to work with the standard intake that comes with the built-in intercooler and everything on the stock Supra.
Yeah, exactly. Yeah, I think it should have there's an additional scan. So this this right here is where the throttle body lives, and this kind of big brick section, I don't have a complete scan, but this brick section is all air-to-water charge air cooler with little short squat runners coming right out of the core into the head.
Yeah, when I was looking at that, that must have been a fun part to design too. It's got all kinds of crazy ribs and stuff on it with the intercooler built in. I'm sure that was fun for the OEM to build.
Yeah, it's a pretty impressive piece because it's all plastic, but it's got the metal core in it, and it's different parts that are bonded together. It's a really cool piece of design. I'm sure it'd be definitely an interesting challenge to work on something like that. It's pretty neat.
Yeah, it is really neat. If you're watching and you haven't seen that part of that Supra engine, it's pretty cool. You can look it up, or even if you watch the Papadakis engine breakdown, you can see it in there a little bit when they built their engine. But it's a cool design.
Yeah, and it's great for something like this. You have a nice, simple, short charge pipe, so you don't have flow losses through that whole system.
Yep.
It seems like the OEM intercoolers support quite a bit of power, but there's, of course, the aftermarket now has options. Like the CSF has one that's all machine billet aluminum intercooler intake manifold that it has the same mount locations, so that works perfectly with our turbo kit and
sure
gives quite a bit more cooling capacity. So it's amazing to see what people are doing with this platform.
Yeah, absolutely. Obviously, it's still relatively fresh to the market, so people are still kind of digging into it. And now the 6-speed is available, which is cool. I'm a stick shift kind of guy, but
yeah, I am as well. But I guess for something like drag racing, like for the guys at Titan, it's hard to beat an auto. But
yeah, yep. Cool. So, what kind of numbers does this make? Do you guys have any dyno info on this yet, or do you have customers running these?
Yeah, so the best dyno sheet that I have was it was a great test. It was Papadakis Racing again that did it, and they went directly from the 2-port manifold to a 6-port head with the 6-port manifold, and the only thing that changed was the head and the manifold, and it was the same turbo, same cams, same everything, just the head swap and the manifold swap. And I think they picked up a little over 200 horsepower at the rear wheels.
Wow.
Yeah, without nitrous. Yeah, same turbo. So there was definitely, the 2-port head works well, and you can make a lot of power with it. I mean, I think Steph was probably the first person in the world to demonstrate the 2-port head could make over 1,000 horsepower, but the 6-port head's definitely a better way to go.
Yeah, that is significant.
Oh, and I guess the number that everyone wants to hear, I think without nitrous he made 11 or 1,200 horsepower at the wheels.
Excellent.
So Titan has their shop car, I think, is making around 1,100 wheel horsepower as well. So
yeah, and I mean, for people watching it, the power delivery, like your role in getting the power to the ground, is really important for the driver in Formula D, right? Because you would assume, like, not knowing much about drifting, you would just make the back really stiff and put some hard tires on it and just let the back end swing around or something. But that's not at all how those cars are set up, right? They're basically like time attack cars that are super, super grippy, and it's really up to the power delivery to overdrive that. You know, they've obviously got their hydraulic brakes, but
Mm-hmm.
but you know what, you have assisted in getting the driver is the critical piece of actually driving a car for Formula D.
Yeah, it's amazing how much grip it takes actually to have a car going sideways 100 miles an hour. It's
In
those
control,
cars
yeah.
are like totally unbelievable.
They are very cool. Very cool. Amazing. Well, is there anything else you'd like to show us while we're here? I guess we are getting around that point in the episode. I could probably stay here and talk about this all day. Somebody's going to have to get the shepherd's hook to get me off. But is there anything else that sticks out to you that we haven't talked about so far?
I don't think so. I think we've covered a good bit. I think probably my key takeaway is that with some pretty standard basic CAD features and functions, you can get from a concept to a finished product like this. And if anyone out there needs help sizing their turbo to their turbo project, give us a call. We can help you out with any turbo that you need. But yeah, I think we've covered all the stuff that I have to share.
Very cool. Well, thank you so much, man, for coming on. We'll definitely stay in touch. I had a blast talking to you today.
Definitely.
As far as follow-up stuff, I think you can go to the Full Race website, right? Or there's Instagram or whatever. You can follow you guys there and get into all sorts of cool stuff. I was looking at that when we were on a call the other day, and there's some super cool stuff in there that you can run through and see what's going on. Yeah, and thank you so much again. We'll wrap up this episode then, and we'll get it moving on. As far as what's coming up for SOLIDWORKS Live Design, we have a few episodes that are coming up, sort of a trifecta, a Titan trifecta that's coming up with 3 manufacturing. A different Titan, I should mention, than the Titan that we've been discussing today. Different Titan, and we've got those 3 episodes that are coming up that are going to be an absolute blast. We've got a little reel that you can see that we'll put up here in a minute once we wrap up and sort of get an idea of what's coming up for those episodes. But those are going to be a ton of fun, I'm sure. So thank you, Matt, again. I really enjoyed it, and we'll see you guys. Absolutely. We'll have to shoot for another project with you sometime soon, because this was a blast.
Definitely.
Absolutely. All right. Well, thank you, everybody, for tuning in. We'll see you all in the Titan Trifecta series, and we'll catch you next time. Bye.
Tuesday, Wednesday, Thursday, you cannot miss our explosive Titan Trifecta edition of Manufacturing Live, Live Design, and SOLIDWORKS Live. Back to back to back. We will be broadcasting from Titans of CNC headquarters in the Lone Star State on July 19th, 20th, and 21st. Get yourself over to live.solidworks.com to add each of these episodes to your calendar now. Get ready for the Titan Trifecta. See you there.